Hello everybody. Welcome to this chapter Diagnostics in Electric Vehicle Subsystems. The first lesson or video in this module is Diagnostics for High Voltage Battery Systems. So to further continue, diagnostics in high voltage battery system of electric vehicle is critical function to ensure safety, reliability, performance and compliance with regulatory standards. Okay, and high voltage battery systems typically operate at voltages between 400 volt to 800 volt and sometimes more. Already understand this value very carefully. 400 volt to 800 volt is a very high voltage, and this is the voltage at which the battery systems operate, and sometimes more and are tightly integrated with other vehicle components. A robust diagnostic framework is needed to detect and handle faults early and prevent catastrophic failures. And just like IC engines, even EV vehicles require a robust diagnostic system which can predict the fault to ensure catastrophic failure and to enable preventive maintenance. Now, the key objectives of HV battery diagnostics safety is prevent thermal runaway, overcurrent, over voltage, and electric shocks. Now, when it comes to performance, maintain optimal battery function and longevity. Compliance is and when it comes to compliance, it meets regulatory requirements, UNECE R100, ISO 16469, OBD regulations for electrified vehicles. Now, when it comes to serviceability, it aids in troubleshooting and root cause analysis during maintenance. All right. So these are the key objectives you should always have in mind when you plan for diagnostics of high voltage vehicles. Now, when it comes to diagnostic architecture of HV battery system, the HV battery diagnostics are typically handled by battery management system, which includes cell supervising circuit, acronymed CSC. It monitors the cell level parameters. And when it comes to battery management controller, central control and computation. Next important building block is communication interface, which comprises of CAN, LIN, and Ethernet to interface with other ECUs, and sensors, voltage, current, temperature, and insulation, contactor position, etc. So these are the various building blocks of the diagnostic architecture. Okay. Now to proceed further, what are the various diagnostic functions in HV battery system? We spoke about the goals, we spoke about the architecture. Now we will see about the functions. Let's see the detailed breakdown. First is voltage diagnostics. When it comes to voltage diagnostics, first is cell over voltage and under voltage. All right, this is monitored per cell and the trigger conditions is greater than 4.2 volt or less than 2.5 volt. So naturally there is a outer limit and a inner limit or a lower limit. Now when it comes to effects, BMS may isolate cells or shut down the pack. Okay, next is module pack voltage imbalance. All right, detects uneven charging, discharging, impact on state of charge estimation, and safety margins. Now, when it comes to temperature diagnostics, cell over temperature, under temperature. Okay, now sensors are placed near or inside modules and protection limits. What is the protection limit? 60-degree max and minus 20 degrees minimum. Okay, now these are all falling under the purview of temperature diagnostics. And when it comes to thermal runaway detection, look for rapid rise in temperature, early shutdown of the system. All right, now considering thermal sensor faults, open short detection on thermistors. All right, to proceed further, what are the current diagnostics? When it comes to the current diagnostics, overcurrent, which comprise of the charge or discharge, exceeding rated capacity if it is greater than 2 coulomb rate, and short circuit detection in pack or in cables and may trigger pyrofuse or high speed relay. Also, when it comes to sensor drift and fault, a comparison between redundant sensors. And to proceed further, next important objective is insulation monitoring. And when it comes to insulation monitoring, high voltage systems must be insulated from chassis. Insulation resistant measurement. All right, insulation resistant measurement must be, for example, greater than 500 kilo ohms. Now, when it comes to ISO 64693, it mandates continuous monitoring. And when it comes to fault, leakage to ground or chassis, and isolation fault may shut down high voltage output. All right, these are all the reasons why insulation monitoring is of such primary importance. Now, coming to contactor and relay diagnostics, stuck open contactor measured using voltage when measured using voltage drop across contactor and control signal. And when it comes to pre-charge circuit diagnostics, failure in pre-charge resistor path detection, and when it comes to welded contactor detection, post open voltage verification. All right. So next important thing is state estimation validation. This is a very important reason why diagnostics is extremely important. The first reason is state of charge, diagnostic thresholds for error in estimation. Okay, so state of charge is a very important parameter, and again is state of health, monitors degradation, triggers warnings if below thresholds. And when it comes to state of power, it helps identify limits on acceleration and regeneration. All right. So to proceed further on the functions, next is balancing circuit diagnostics. It detects the malfunctioning balance of resistors and circuits, and also active or passive balancing operations monitored. Yeah. Now, when it comes to communication diagnostics, CAN, SPI, LIN faults between BMS modules, timeouts, uh, cyclic redundancy, check failures, data length misbehaves, data length mismatches, message counters, all these come under the purview of communication diagnostics. Now, when it comes to high voltage interlock loop monitoring, HVIL detects unauthorized access for detection of HV monitors. Now, when it comes to open HVIL, battery system is disabled, required by regulations for technician safety. Now, when it comes to memory and software diagnostics, flash RAM test failures, watchdog timer reset detection, faults in bootloader or firmware updates via the over the air. Okay, so to summarize, what are the diagnostic methods? Diagnostic methods are onboard diagnostics, which stores the diagnostic trouble codes, complies with OBD2 and EOBD standards. And next method is self-diagnostics, continuous monitoring by the BMS, and end of the line performed in the factory during uh, vehicle battery commissioning, and service tool diagnostic used at service centers via OBD port. Now, when it comes to remote diagnostics cloud, fleet health monitoring via telemetry and AI/ML for predictive maintenance. Now, when it comes to common DTCs in electric vehicles, the very common DTC is P08A80, which means replace hybrid battery pack, and P1A10 battery cell imbalance, and P1E100 HV battery contactor failure, and P0AL6 isolation fault detected. Now, when it comes to functional safety and cyber security, diagnostics are safety relevant as per ISO 26262, uh, and it is a ASIL C and ASIL D rating when it comes to functional safety. Now, when it comes to HV battery, is a safety critical element, and cyber security ensures diagnostic services can't be misused. So you have to be clear that cyber security services should not be misused by doing something like spoofing or false DTC injection or denial of service. Now, when it comes to regulatory requirements, UNECE R100 that takes care of the electrical safety and insulation monitoring, And OBD regulations for EVs, which includes the US EPA, European EV OBD, they mandate the fault detection and standard DTC communication. And when it comes to ISO 6469 series, safety of electric vehicles, and IEC 61508, ISO 26262, safety related diagnostics and fault handling. And comes to tools and technologies, diagnostics tax UDS ISO 14229 and ODX ISO 22901 and OTX ISO 13209. Now communication, diagnostics over internet protocol, CAN FD Ethernet, and coming to tool chains, Vector Cano, Canalizer, ETAS Inca, DSPAS, NI Lab View, and when it comes to testing, important technology is hardware in loop and battery in loop. All right. So these are all the various tools and technologies which are covered in the diagnostics for electric vehicles. To summarize, diagnostics in high voltage battery systems are multi-dimensional and essential to ensure safe operations, to enable serviceability and compliance, and to support prognostics and health management. I already clearly explained to you what is meant by prognostic. So I hope all of you know what prognostics means. Okay, thank you.